According to a paper published in Science Advances, a newly developed device has the potential to completely change our lives, just like many technological breakthroughs before it. When you hear this, what comes to mind? I don't know, but our topic today is about one of the most fundamental pleasures of life: taste. A group of scientists from Ohio University claim that it is possible to experience the taste of a chocolate cake without consuming any sugar and with almost no calories. And not just that, but without there being an actual cake in front of you. According to the published study, the futuristic vision that the Matrix predicted decades ago now seems to have become a reality. For years, augmented reality enthusiasts have dreamed of a VR device that could allow people to taste. Now it has been made. That means, while playing a game or watching a movie, when you see a delicious cake, you can actually taste and enjoy it. Think even bigger. Who would say no to a device that grants access to flavors with little to no calorie intake? You will be able to eat as much chocolate as you want without gaining any weight. Or imagine millions of people eating chocolate without producing a single gram of cocoa or sugar. Let's take a deep dive into this revolutionary development that has the potential to change our lives, looking directly at the peer-reviewed study. Recent advancements in virtual reality and augmented reality have strengthened the bridge between the virtual and real worlds through human-machine interfaces. However, despite extensive research on biophysical signals, taste perception, one of the 5 fundamental human senses, has seen limited progress. Considering that nearly 80% of people on this planet live to eat, this absence has been a major obstacle in turning virtual reality into an unbelievable experience. This study presents e-taste, a bio-integrated gustatory interface that addresses the missing chemical dimension in current VR and AR technologies. Let's cut to the chase and explain how this system works with a concrete example. When I put on the headset, a slice of chocolate cake appears in front of me. Is it really there? No, but the taste I'm about to experience is far more real than I ever expected. E-taste, an advanced gustatory interface, is designed to deliver this virtual experience using chemical sensors, micropumps, and specialized hydrogels. First, the system constructs a taste profile of the cake. The sweet and rich texture of chocolate is simulated using glucose. The slightly tangy cream is replicated with citric acid. The buttery and slightly salty taste is created with sodium chloride. The mild bitterness of dark chocolate is delivered via magnesium chloride, and the deep, umami undertone that completes the flavor comes from glutamate. Everything is prepared and ready to reach my tongue. As I bring the cake to my mouth in the virtual environment, the electromagnetic micropumps activate. The hydrogel layer, which touches my tongue, releases the taste components in carefully calibrated proportions. At first, I taste the sweet and creamy notes, then the slight saltiness and acidity balance the experience. It feels exactly like eating a real cake. In reality, I am consuming 0 grams of sugar, yet my brain fully accepts these flavors. I'm no longer just seeing food in VR. I'm feeling it, tasting it. This technology could one day open doors for people who have lost their sense of taste, enable remote dining experiences, or completely revolutionize gaming. But right now, all I can think about is how long I can make this cake last. Now, here comes the most exciting part. A slice of chocolate cake typically contains calories. According to the study, the system delivers taste components at a micro scale, only in microliter quantities. This means that the amount of chemicals used is so small that the calorie intake is negligible. And this is where things get interesting. Eating cake without consuming any calories. The study states that this system can analyze tastes and create new food profiles based on its analysis. However, in its initial phase, it will rely on predefined food profiles. If a certain food has been previously analyzed, its taste components can be drawn from an existing database and directly transmitted. For instance, if a user desires the taste of chocolate cake, the system automatically activates a pre-programmed balance of glucose, sodium chloride, and glutamate. So how does it work? The e-taste system uses specific chemical components to create the 5 basic tastes. These chemicals are detected by sensors, processed, and delivered to the user through highly precise pumps. For sweet taste perception, glucose is used. For sour tastes, citric acid is applied. For salty taste, sodium chloride is introduced. For bitter sensations, magnesium chloride is utilized, simulating the bitterness of dark chocolate or coffee. Lastly, for umami taste, glutamate is used, mimicking the deep savory flavors found in meat, cheese, and fermented foods. The e-taste device delivers these 5 chemicals in precise proportions according to pre-programmed taste profiles or by analyzing real food and creating a corresponding chemical composition. This makes virtual foods much more realistic in terms of taste. For example, if you want to drink coffee in a virtual environment, the system recreates a predefined coffee profile using these 5 chemicals. The hydrogel strip in your mouth slowly releases the liquid, and since you already see yourself drinking coffee on the screen, your brain fully registers the experience as real. The chemicals used for taste simulation are stored in small liquid reservoirs within the e-taste device. Each chemical is kept in a separate airtight tube. When activated, electromagnetic micropumps precisely transfer the liquids through microfluidic channels to a hydrogel layer that touches the tongue. The tubes are extremely compact, allowing the device to remain portable. Each liquid reservoir holds only a few milliliters, and the micropumps operate at microliter precision per second. This ensures a controlled and consistent taste experience with every use. The tubes can be refilled or replaced, allowing for the introduction of new flavors over time. This compact system is designed to integrate seamlessly with VR and AR applications to provide a realistic gustatory experience. Now, what does the e-taste device actually look like? The device is designed as a small, portable module that can be integrated into a VR headset. Its main components include chemical reservoirs, microfluidic pumps, fluid transport channels, and a hydrogel layer that makes contact with the mouth. The system is designed to be lightweight, wearable, and seamlessly integrated with VR equipment. Tests conducted with the e-taste system have shown promising results. Participants were able to distinguish different taste intensities with an accuracy of approximately 70%. In a long-distance test, taste data was successfully transmitted from California to a participant in Ohio. In another experiment, 5 different virtual foods, lemonade, cake, fried egg, fish soup, and coffee, were presented to participants. They identified the flavors with an accuracy rate of 87%, proving the system's ability to recreate tastes. Users also appreciated the ability to adjust taste intensities to their preferences. In terms of health effects, the paper states that the chemicals used comply with American food standards. However, we don't yet know whether experiencing virtual food might trigger intense cravings for real food. If any of our expert viewers have insights, they are welcome to share their thoughts in the comments. The results indicate that e-taste is not just a tool to enhance VR experiences, but also has potential applications for individuals who have lost their sense of taste and for sensory research. Future developments aim to expand the range of flavors and integrate additional taste components. See you next video.